All right. Hey, everyone, and welcome to another Crystallize live stream. I'm Brendan, and today I'm joined with Sebastian, who is our CTO here at Crystallize, and also the head of the team that I'm in, which is the developer experience team as well. So
Hello,
welcome on
everybody.
board, Sebastian. How are you doing?
Good, pretty good. I'm glad to be here with you, Brendan. I think
Perfect.
it's
Yeah.
one of my first live streams, so excited about it.
Great. Yeah. Well, welcome to the stream. It's I know you have a lot to share with us, and I'm really looking forward to going through this. So today we have a really interesting topic to talk about, and this is working locally, because oftentimes, like when you're a developer and you're working locally, you have an environment that's very different to what you actually have in production, whether you're, say, developing on a different operating system, for example, or you've got this whole different infrastructure set up. And then, of course, in production, you might have things like HTTPS, which you don't necessarily have in development, and a whole bunch of other things that are mismatched between the environment that you're developing in and the environment that you're deploying to. And your take on this, Sebastian, is that that's a bad approach, right? We can do a lot better than that.
Exactly. Yeah, kind of. We want the dev production parity, kind of. So
Right. Yes.
we basically what we want to fight Murphy's law, right? We want to be sure that when we're gonna push something to staging an environment first, we were able before as a developer to to get all the problem that we should have gotten, so we can get it first, so it's not it won't appear on staging and even production. We don't want that in production, right? So we want to reduce the feedback loop. This is exactly what we want to do when we want to optimize the local development environment. It's to reduce the feedback loop of the team, developers, project management, and client if you're working with a client.
Right. Yeah. So the idea would be to keep your environments as similar as possible: development, staging, production, all that.
Yep. Yeah. Okay. So first the context. Usually, when you start a project, most of the time, you would use npm, right? In the JavaScript ecosystem, you use npm or yarn, and you get your application up and running really quickly, right? You do yarn start, and boom, you have your project running. This is good, but this is on localhost and on a specific TCP port, and this is also HTTP. So you don't get HTTPS. We're going to go into the details probably a bit later on why we don't have HTTPS right away. And because of that, you are already just this, you're ready to develop, but you are already behind production. In production, it's not going to be localhost, and it's going to be HTTPS, and it's going to be probably another HTTP port, right? It's going to be probably port 80 or HTTPS 443. So you want to start with something better. And it's even more complex when you have different component part of your application. Usually, and if you're using Crystallize, we'll get the service API, which is going to be our API for business logic and the backend stuff. And then you have the front end, which is also running somewhere else. So you actually have two sockets, right? One for the front end, HTTP localhost 3000, for instance, and the service API HTTP localhost as well, and 3001. And you might have other components. We are working in the microservice industry, right? So you have a lot of different microservices, and you might want to run everything locally. Maybe not everything, but most of the components that you can have locally, to me, should run on your local development, so you can experience the whole project as a developer.
Yeah, exactly. All on your single machine without having to worry about some third-party services or things like that, right?
Yeah.
Nice. So what are some of the main differences, I guess, that you'd identify between your local environment and, say, a production environment? Like, what are some of the key things that would be different? You've mentioned the domain, like the local host versus like where you share local host as the host name, but just different ports. Whereas like in production, you could have two different domains entirely, potentially, if they're deployed to completely different places, for example.
Yes.
But is there anything else like on top of this?
Yes, definitely. So first, some people believe, and they're right, that HTTPS versus not at HTTPS, it should be just an architecture concern. Sorry. So it means somehow that your application should not worry too much about being behind HTTPS or not. That is true. That is true. But it doesn't mean that as the developer, you should still have HTTPS on your computer. And it's more than just HTTPS actually, because as you mentioned, Brandon, there is more. There is more. First, when you have localhost everywhere, then you share the cookies, right? So in many projects, we still have cookies to enable authentication, for instance, or to share information between the client and the server. And if you are on the same domain, then you share the cookies. So if in production you don't share the same domain, it's not going to be that easy to share a cookie between your front end and your back end, for instance, if we keep the same example. So this is one problem. Cookie sharing, it's going to be easy on your local if you're using localhost, but it's not going to be in production. And you will see that only when you're on staging. And then you have another thing. It's a security things. You have the cross-origin resource sharing, aka CORS, CORS. And same, if you are on localhost, it's going to be really easy for you to load the front end and do a fetch to the service API or to your backend on your local development. Nobody's going to yell at you. The browser is going to let you do that. But once you arrive on staging or in production, hopefully you'll see that in staging, but you're going to get blocked. Your browser is going to say, hey, I don't want to discuss with this other origin, or you need to enable some kind of things on your service API to allow me to call that. But if you are local, so those are the two main ones. And then I would say that you have other things. Some features are only enabled on HTTPS. Thankfully, browser today allows they allow you to use those features if you are using localhost. So your localhost, it's kind of a specific host name, right? Which is only your loopback.
Right. So the browser sort of knows and allows certain things there.
Exactly. Right. Exactly. Yeah. And one good example is service workers. Service workers are only available on HTTPS unless you are on localhost. So you can enable them on localhost. HTTP2 on the other side, it's going to be HTTPS only. So if you want to test your application, you want to improve performances, at Crystallize, we are milliseconds enters, right? So we want to win those milliseconds, and you want to be able to test locally if adding the HTTP2 headers to enable more, to enable the push of the resources in the same response. You want to try that on your local. You don't want to push to staging, wait and check. You want to do that in your local. So you will want to have HTTPS at some point. Then we have the notification API. This is HTTPS only, but again, available on localhost. If you want to use a secure cookie flag as well, you have to be behind HTTPS just to be sure that it's working. So again, we want the parity, and we want to be sure that we are as close as possible as production. So we fight Murphy's Law.
Yeah, makes sense. And it seems like the common sense thing to do in terms of fighting Murphy's Law. Like, you want to reduce anything that can go wrong to being as few points as possible. So I mean, you've pretty much mentioned everything about HTTP only versus HTTPS then. But what would the solution be to this? Like, how, in terms of, if I'm a developer, how can I go about setting up my local environment to be similar to production? Do you have any examples of that you could share maybe?
Yes, sure. And first, a little bit of theory before. It will be probably easy for you as a developer to change your domain locally, to change your etc host, to say, okay, I want my service API to respond to that domain, which is going to be localhost, and that you can do that in your /etc host. But so you can do that for the service API, for the backend, and for the frontend. But then you're still in the HTTP. So it's not really enough. If you want to go on top of HTTPS, you need to know a little bit more about HTTPS is working, and to make it work for your browser, you need to have certificates. So the first step is to make your computer certification authority. And to do that, thankfully, there is a tool which is called MK-Cert, and it is really simple to install. You do MK-Cert install. Actually, we have a blog post on that, so I'm going to just share this with you. So that would be what you put on your etc host to enable, the custom domain on your local, and then you want to install certificates. So you install that tool, and then you will create those certificates on your machine. So that way, you can have different host name on HTTPS, and you can start to be like in production. So in your application, in your local development, you will have to manage CORS, and you will have to manage the cookie sharing the way you should manage it in production. So all the problems that you would get in production, you would get them locally, right?
Yeah, and just a note that the blog post for this is linked in the description of the video as well.
Yeah. Cool.
But yeah, that seems like a very sort of simple setup with to get these certificates sort of up and running. Just with that.
That's one thing. So you get the DNA things enabled on your computer. Then you create the certificates on the computer. But then you are still going to run the application on Yarn with Yarn or NPM, and you have to have some kind of proxy which is going to understand HTTPS and which is going to forward the request to your application, right? Those are still in Node and Node or any kind of architecture, actually, right?
So this could be like in Nginx reverse proxy, or I see you've mentioned here the Caddy server with a config for reverse proxying to the hostname as well.
Exactly. And that I have a quick example if you want. We can dive a little bit more into some code and some configuration if you'd like.
Yeah, definitely. It's I think it's great for everyone to see what the sort of config would look like and see how it runs. And
all right, so let's do that. So let's have a look at some code about how to organize a project when you want to have your local development a little bit more close to production. So first, this is a simple project. This is an open source project that we have on Crystallize API GitHub repository. And the way we organize the project today, we have usually one mono repository where we put the service API and the front end. Both of those folders, it's just an NPM application. So I can definitely go to the front end and load my front end, right? The same way you would do before. And that will listen on some HTTP port on my local machine, right? It could definitely be localhost here that would work exactly the same way. So this is, by the way, we are using Remix here, but yeah, this is the front end. Then I can load in another, I'm going to close that one, but I can go to the service API and do exactly the same. This is another tech, but this is still Node, and it is going to run my my service API in, I think this. So I have a service API returning me just a JSON. So I'm HTTP and localhost. But now I would love to handle HTTPS on top of that. So this has been done already if you follow the blog post, but I have the certificates already that have been generated. And what I usually do is in the middle of front-end and service API, I have a provisioning folder in which I will save some stuff that are not related to application. We still want to decouple the application from the hosting, right? This is a very, very important subject as well. You want to be decoupled. So provisioning dev will contain the certificate that I'm using locally and some configuration. We're going to come back on Docker later. For now, we didn't mention Docker at all. You'll see that it's going to be interesting to have Docker for some services later. But yeah, instead of Nginx that you mentioned, Brandon, you can use something else. And today, Caddy, so it's Caddy server, it's really, really, really simple to use. You can see. So this is the configuration of the service, the reverse proxy that I'm using. I don't know why the syntax highlighting will do that, but anyway, this is correct configuration. You know, it's simple enough to say, okay, this is my certificate. I want to proxy to this HTTP port. For this domain. This is my front end, and this is my certificate. I want to proxy to this TCP port, and that's pretty much it. Now I have that, I can just run the Caddy server.
Yeah.
And I want also to run the front end and the service API. So I think this is a good time for me to introduce something that I will put in any of my projects as well, is a Makefile. It could be a script, it could be a bash script, but what's cool with Makefile, it's, you know, everybody's using, I mean, a lot of people are using Makefile. It's a standard. Kind of. It's good to rely on standard, right? So usually I will have a target on Makefile, make serve, that is going to start my Docker. We'll come back to that. Run the Caddy server, and then serve the front end and the service API just using npm.
Yeah.
Okay. So
makes sense.
So now if I do this, I do make serve automatically. I'm gonna have everything will be loaded automatically, of course, running. So this is still working. So you can still connect to your npm instance directly, right? It doesn't change anything. It's still there. But on top of that, you can go through HTTPS and your custom local name. So now, so we are on top of HTTPS. So Caddy server will handle the certificate, the HTTPS, and will forward everything to my npm. This is true for the front end, and this is also true for the service API. I have the service API on top of HTTPS. So now I have two different host names. I have HTTPS, and I have HTTP2, by the way. So this is interesting to see. When I load this page, you'll see that the doc, load this. So here we go. So here we are HTTP2. If I do exactly the same in my localhost on the TCP port that was running, so I think it was 3018, and now I do exactly the same, it's going to just be HTTP1. So this is one example of why it's nice, because now if I have HTTP2 in HTTPS, I can enable some kind of header to improve performance in the response. So you have HTTP2, so you can use whatever you want to do on top of HTTP2. So that's now, just with this, you are in a much better way. The developer experience should be much better for you, because you have everything that you need close to production, and you have some kind of automation for your team. Because again, this is an important part, right? When you're working on a project, you are not working alone. So you want something for your coworker to be simple to install. And when you start to say, okay, so we need the front end and the service API, right? This, we have to have it. But then you need to have a Caddy server. Then you need to install the certificate. Then you need some kind of scripting to run everything at the same time. So this is where the automation are coming handy. And this is why, to me, Makefile is kind of cool, because the documentation to install the project it's quite simple.
Yeah.
The domain, the certificate to do, and we can even automate some stuff. We didn't want to automate the writing inside your HTTP host, but everything else is automatic. So when you do make install, so everybody will read the README and run make install. That's gonna install the certificate, do some kind of custom configuration, with the .env, and then run, and then in npm install, and then we have make serve to serve the project, and boom, we have the application ready for anybody. And this is kind of cool.
Exactly. That's super nice. You sort of get everything out of the box, I guess, without having to do a whole lot of manual scripts and stuff yourself. It's all there, and it's in a convention that, I mean, a lot of people use, at least the majority of people have used at least at some point. So yeah, I mean, that seems really straightforward to me. And you mentioned there's Docker there as well.
I was waiting for you to ask. Yes, because now we have HTTPS. We are production kind of ready. Probably in production, you'll get more services. Probably you might have HTTP cache in front of your architecture. And
Right.
if you have HTTP cache, for instance, you want to be able to try that you can purge some URL or some object in your HTTP cache, whether it is Fastly or CloudFront or Akamai or just Varnish in your architecture. So you want to be able to have that service locally to test your development, right? Again, the goal is to be close to production, to test everything. And even simpler than HTTP cache, you might want to send email in your project. And to send email, you have two ways of doing this, right? Most of the time, I guess what I've seen in the past is people will set up the application to send emails through their Gmail account or through their professional Gmail account. It's so simple. You install the Note mailer, and then you set it up to send email through Gmail. But here we have two crazy problems. First, if you do that, be careful. Don't use production database, because then you can send an email to all the database and the client won't be that happy. And second, you might not want to use your Gmail, and you don't want to put the password, and it's not convenient to use your email address. You have services for that. I'm using Mailcatcher, but you have also Mailtrap. You have many services. What I like with Mailcatcher is it's simple. There is a Docker image that you can install on your computer, on your project, and then you get the SMTP socket available, and you have an HTTP interface, so you can look at the email that you will receive. And so this is when we can introduce Docker into this automation. So to introduce Docker in the automation, first, Docker it would be the application architecture things, right? It's not connected to your application itself, so it is in the provisioning folder, so it's decoupled. So we have the Docker Compose, and in the Docker Compose we have Mailcatcher, and in this project we have also Redis, because we kind of want to have a simple database for the service API. So just doing this and Docker Compose up, you get Mailcatcher and you get Redis enable on your project. So that's it. And in the automation, it's just Docker Compose up, and that's really it. So every time I do, for instance, make stop, I will have my Docker. I will have nothing into Docker, and if I do make serve, the system will start Caddy, start the 2 npm application, and start the Docker container. So now I have Mailcatcher and Redis.
Perfect. Yeah.
And then they're ready to use. In my application, I can say, so this is in the service API. I can say, okay, I have the mailer, and here I will retrieve the information of the mailer from an environment variable. Again, we stick to the logic, we want to decouple the application from the architecture, and we also want to decouple it from the configuration. So we can have build that are immutable, and the application actually get the configuration from the environment variable. So here I can say, okay, my mailer is localhost 3021, and which is actually my container, my Docker container for my catcher, which enables me, for instance, in the project to send email. So I can place the cart. It's a very quick demo, but when I do that, I can put any kind of email up, and then it didn't work. But oh yes, it did. I didn't reload.
Nice.
So
Right. Yeah.
then I received the email, and I can continue, my work on the application. So this is just an example of Magic Link, but it's really convenient to test, and this is also something that enables even a more dense feature. You can reach mail catcher through API here, so you can actually do functional tests, checking the email from your container. So you want to test the whole checkout process, you can do it locally.
Right.
With
Yeah.
or something like that.
That's perfect as well. And then, so you mentioned you could have some functional tests here, some integration tests, perhaps. How easy would it be to have this set up in CI as well? So it's just Docker, right? So it should be fairly easy to have this sort of mail catcher set up in CI too.
Yes, and that's an important point that you are mentioning here, because for this project, and again for the team, we want this local installation to be working all the time. So we actually want to test that architecture. We want to be sure that every time we commit, that someone else can git clone and make install. Because if you don't have that, then you're back to the problematic from 2000, right? Then when you ask your coworker to work with you, he git clone, and then they spend 3 days to install the project. This is crazy, right? So we want to avoid that. To avoid that, we have CI now. So you can actually run the command, run the makefile from your CI and run the test through the CI. So you're sure that the project is installable in 2 minutes, and you can run the functional test on top of it, because in your CI, you're going to start the Docker image. So you're going to have the container, you're going to have CAD file and everything. I have an example of that, actually. Do we? Oh, yes, we do. We do have an example of this, but not in this project, because we are providing a starter kit as well. So if you go to the GitHub of Crystallize, you see this starter kit, which is exactly what I mentioned so far, but it's empty. So the front end is completely empty. The service API is almost empty. And then you have the provisioning folder, which is also almost empty. You have the the codified configuration, the Docker Compose with just mail catcher. And I don't see the trial. I was looking for the GitLab CI somewhere, but we have it in the blog post. So we have the makefile for the starter kit.
Right.
I'm gonna just share what we have on the blog post then, because I'm pretty sure I put it. Yes. So that would be what you can put in your CI, and install KDE, make, and curl. This is just installation of the certificate thing. Then you enable the local domain in your CI. You run the make install. You start npm. You start npm for the front end and for the service API. You run the reverse proxy, and then you can even check. So this is simple here. We just check that the home page is loading. But here you can run Puppeteer and do any kind of scenario that you would like. And doing this, you run your test, but you also ensure that those commands and the make install actually is working. So you have a continuous integration here. You have a continuous check on each commit, each pull request, that the local environment is installable. So there is no way someone can come to you saying, hey, I tried to install the project, but it doesn't work on my computer, because you have an easy answer. Then you have, hey, it's working in Travis, it's working on GitHub Action or on GitLab CI, right? So if a robot can do it, you can probably do it. So it's a bit harsh. It's made for that, right? Why do we do this? So that's the trick. You keep everything consistent. You reduce the feedback loop. Yeah. So it's improvement of the first time to success for a coworker, because they can work, with you right away. And then it's reducing the feedback loop, because it crashes. It will crash as soon as possible. It has to crash as soon as possible. This is the way to do it for me.
Yeah, that makes total sense. I mean, it seems like very logical and proper, like good practice way to go about this process. And it, I mean, I guess just to summarize, like we've gone through why it's important to have your local environment as close to production as possible. But we've also gone through the whole steps of like not just production and local, but you've got CI, and then again for staging as well. Like it's the whole thing. They all need to be mirrored sort of environments to one another to give you the true benefits of reducing the things that can go wrong, as you mentioned regarding Murphy's Law.
Exactly.
Yeah, and also for enabling the developer experience for getting up and running, and just the overall experience as you're developing as well, with like the mail catcher, for example, getting emails instantly versus having to wait for some third-party service in your development environment to send an email to some external email address that you don't want to have associated with it. But that's
And the good part is, I don't know, all the teams are organized differently, right? But in a professional project, usually you have the lead developer who is, or she or he can be, those person are usually a little bit more DevOps, so they can initiate the project and this automation. And once this is ready, then anybody can work on the project, because you just have to have the README, git clone, make install, make serve, and boom, you can start developing. Even if you don't work on the service API, you can use the front end. You can work on the front end, and you have everything locally. So
exactly.
Ready to work. You have everything ready to work. When it starts to be interesting, but that could be for another live stream, is for all the services that are not able to be replicated locally. And guess what? Crystallize, you cannot install Crystallize on your computer, right? You want to use the tenant, which is, it's a SaaS, right? For all the SaaS system that we're using, you cannot replicate it locally. So those tools provide, Crystallize included, using different kind of tenants, a way to be sure that one developer will have access to his kind of or her kind of environment online. And then you have some complexity in the CI, but this is another subject. But it's good to think about it from the beginning, usually.
Yeah, so it sounds like we have a part 2 of both the blog post and the stream coming up. So.
Exactly. It would not be the local developer. It would be connected somehow. Yes, for sure. Yeah.
Definitely. I look forward to that. That'll be great.
Well, so maybe to wrap up everything, unless you have other question, but we have it's on GitHub. So even the project that I showed, everything is on GitHub.
All of the links for these projects that you've showed and the blog post, of course, will be in the description for the stream as well. So you can find that there and check out this furniture remix boilerplate, the blog post, and the other tooling that we've mentioned as well.
Yeah, cool. And then if you have ideas and you want to contribute to what we're doing at Crystallize, you don't hesitate. This is also something that can be done.
Absolutely,
yeah.
Yeah, we're always happy to have contributions to our open source project. It really helps us just to keep the momentum sort of going and get the feedback and ideas from the community as well, so that we can help build something that the community can use and not just what we think the community can use. It's great. Yeah.
That's might be another idea of the live stream as well.
Exactly. Yeah.
To contribute to.
So we've got 2 more lined up now. That's great. Yeah. Well, perfect. I think this is a great place to wrap up the stream. I think we've covered pretty much everything to talk about regarding working locally and having your environment as close to production as possible. So yeah, thank you, Sebastian, for joining us here on the stream and explaining all of this to us. It's been really illuminating for me, and I'm sure all the other watchers as well. So thank you so much, and thank you everyone else for joining as well. So yeah, we will sign off now, and we'll see you in the next stream.
Thank you, Brendan, for being the MC here. That's great.
Yeah, cheers. It's always great to host these. So yeah.